Okay, I'm glad all you folks turned out. I'm going to talk about something that I've been doing for the last, as I said, last 3 years at the Non-vertebrate Lab. I found it a lot of fun. I mean, it's one of these things where people who like maps and like puzzles, it can be a challenge and interesting. Plus, you get to dig into a lot of the historical material that's floating around in the lab. So the UT Non-vertebrate Lab has been updating its location data in its database. And the idea here is we're converting verbal descriptions of collecting locations into GPS latitude and longitude. The lab uses the term georeferencing for this work. Other people call it geocoding. There's some arguments about precise terminology, but we're going to use georeferencing. So I'm going to talk about how we go about this, and I'm going to talk about some of the tools that are particularly useful. And the reason this might be of useful to you guys, if you're reading old publications, trying to locate collecting locations, it can be critical. There are a lot of places where without digging into historical naming conventions and stuff, you're just not going to be able to figure out where they are. One of the other things that I've been able to do is once I've got a GPS coordinate, I can confirm a formation using some of these online tools. And again, this third one, you can use Google Maps for most of this if you know where you were, but these tools make it easy to collect GPS coordinates to add to your locations. One thing I want to mention, those of you, you don't need to furiously take notes. These slides are available on the club's website. So if you go to the Paleo Society's website, you go to the meetings page, there's on the home page, there's a meetings button, you click on that, and then there's a handouts thing off to the right, and you go to that and you'll be able to download this stuff. So the Non-vertebrate Paleontology Laboratory at UT is known for its rare and important specimens. It's got a type and figured collection, over 22,000 specimens, and the total repository contains over 4 million specimens, making it the 5th largest collection in the US. It's kind of interesting how the collection grew. It's this historical accretion of stuff. The earliest geological surveys in Texas in the 19th century collected material that's now in these collections. There was work by the WPA during the Depression. Most of that stuff was vertebrate material, but there's some really cool paleobotanical stuff that showed up in the Non-vertebrate Lab. There have been paleontologists in the UT Geology Department for many years whose collections ultimately rolled into the Non-vertebrate Lab's collection. There are collections from other places. Individuals have donated them. Linda McCall has donated a bunch of stuff. Ed has donated a bunch of stuff. We've gotten collections from oil companies. Back in the day, there was a lot, and maybe, I don't know, still today, there was a lot of movement back and forth between oil companies and the geology department. And a lot of the collections that were made while people were working with oil companies ultimately came to UT. And then there are orphan collections from other institutions that have basically decided they're not doing paleontology anymore. All the data on these specimens is captured in a system called Specify. It's built on a MySQL database, but it's specifically designed for natural history collections. And it's used in many, well, you can see 230 organizations in the US and 160 internationally. It's used for all kinds of different collections, herpetology, mineralogy, entomology, as well as vertebrate and invertebrate paleontology. The collection includes stuff from all over the world, but about 60% of it's from Texas. Now, why do we want to, I guess there's sort of a question to ask, why do we want to add these GPS coordinates? You know, there's two things going on. One is we're trying to make available data on these collections without requiring people to go and hunt through drawers in institutions all over the world. So many institutions are funneling data in their collection, in their databases that describe their collections into several international organizations, in particular GBIF and iDigBio. If you guys haven't been to these sites, they're cool sites to poke around in. There's a lot of neat stuff out there. So the Specify database contains all of the NPL's catalog records. And again, one of the things that's, paleontology is getting a little more computational too. So it's great if you're going to do computation over the ranges of things. It's pretty hard to do that if you just have a verbal description of where something was found. But if you have GPS coordinates, you can bring a lot of mathematics to bear on it and do more interesting things. And that's, clearly the first geological survey of Texas in 1958, or 1858. 1958 was a long time ago, but 1858 was longer ago, and they weren't recording GPS coordinates. Before I go any further, I want to thank all the folks that have I've had a lot of fun out at the lab. Most of you knew Anne Molyneux, who was the curator when I first started volunteering. She was terrific. Her enthusiasm is part of what got me involved in the lab in the first place. Angie Thompson, who's no longer at the lab, got me indoctrinated into Specify. Lee Appleton is the current collections manager, and she has put up with endless questions from me about what's the right way to correct something that that needs fixing in the database. And that can be, getting it done correctly can be tricky. Lisa Boucher is the new curator and NPL director. She's spoken fairly recently to the club. She seems to get almost as much fun out of tracking down these obscure locations as do the volunteers. I want to thank my fellow georeferencers. Most recently, I've been working with Ed Bradford and Sharon Lind. Ed's been sitting across from me for about 3 years and has been a sanity check in a lot of these instances where we have something really tricky and difficult to figure out. And, should it be this? Should it be that? What do you think? And his enthusiasm for maps, I like maps, but he really likes maps. So why can this be hard? I mean, you Google stuff all the time, right, and pinpoint it, but you're Googling an address. So what we are georeferencing are these locations, and you get places that no longer exist. Loman's Crossing is underwater under Lake Travis. I'll talk later about Terry's Church. Ranch names have been subject to 100 years or more of ownership changes. So if you get a ranch from the 20s, it's unlikely it's going to still have that name. There are geography and road changes. I had one that was driving me crazy, and then I figured out that a reservoir had been built. The distances along the road didn't make any sense. But once you realize that the road was the road before the lake was built, the reservoir was built, suddenly it clicked. There are numbering systems that are unique to specific collectors. I got this PGCB 15.5. I'll talk about that in more detail later. You got outdated or local unique names. I struggled with this place called Nellen in McCulloch County. Plumber is one, there's a large collection of plumber's material. And Nellen apparently was his name for a place called East Sweden in McCulloch County, but it's not on any maps as Nellen. I was able to figure it out by looking at multiple descriptions of locations around Nellen and sort of zero in on the fact, this must have been an alternative name for East Sweden. And then even more obscure, but these have definitely happened, county boundaries in West Texas were changing at the end of the 19th century and even into the beginning of the 20th. I also had one that predated Oklahoma statehood that said it was found in Texas Indian territory, and it should have clicked immediately, but I found the creek and the town, and they were both in Oklahoma, and then I said, oh, Indian territory, duh, of course. So one of the things this points out is that knowing the date the specimens were collected can be critical in figuring out where they're talking about. Here are some examples, some from sort of easy to hard. Austin along Shoal Creek from 20th to 33rd Street, that's straightforward. 1.5 miles northwest of Mitchell Crossing at the south end of Parks Mountain. That's getting a little trickier because Mitchell Crossing doesn't show up on all these maps. 0.5 miles northwest of Round Rock in Stream, Travis County. Well, what stream? That again, what's going to happen there is that's going to introduce a lot of uncertainty into where the location is. Half block southeast of the end of Travis Heights car line in Travis County. Well, there was a cable car line that went down to Travis Heights. And again, if you get the right maps and you have the right time period, you know exactly where that is. Country Club Austin. Well, there have been at least 3 country clubs places named Country Club in Austin. There was a country club at 30th and Half Street near I-35. It moved out to Riverside for a while, and then it moved to West Austin. So again, this is where knowing when they're talking about it becomes important. Bull Creek Road, after leaving Georgetown Road and crossing the INGN 5 miles northwest of Austin. The Austin INGN is the International and Great Northern Railroad, which is a predecessor to MOPAC, to the Missouri Pacific. And so this tells me immediately something about when this happened. And the fact that it's the Georgetown Road rather than something we see currently, that, I mean, again, IGNN and Georgetown Road get me to the right map, so I can start thinking about what 5 miles northwest means in that context. 11-T-3, that's UT has its own set of numbering, a numbering scheme for identified locations. We'll talk about that a little bit later. 2.7 miles north of Dessie's Ranch in Brewster County. Well, Dessie's Ranch isn't there anymore. Near Terry's Church, this was my favorite recent one. There are two, if you Google this, you can find Terry's Church mentioned in 2 publications that are both geology publications about ammonites that reference each other and don't tell you where it is. And I thought, a church, how hard, you know, the churches are usually pretty easy to find. There is no evidence of any Terry's Church in Culberson County at all. Fortunately, some guys in 2015 revisited this work and went out to the ranch. I had sort of figured out the ranch, but it's huge. They went out to the ranch and they had a precise location for it. I was able to contact them and get a copy of the paper. And if you look on Google Maps, you can see a very faint rectangular outline that's nearly invisible where this church was. So again, these range from easy and relatively invariant over time, older but doable, to really difficult. And that's partly why I like it. Again, it's fun. I like solving these things. Why is, there we go. So we don't only come up with the GPS coordinate, we want to know how precise we think we've nailed this. So there's a radius of uncertainty. You know, if you talk about something that's 10 miles north of Mineral Wells, that can mean a couple of different things. Some people it meant as the crow flies. Some people it meant on their odometer as they were driving in a northish direction out of Mineral Wells. And there's this whole science around producing consistent estimates of uncertainty. What you'd like to do is, even though you know that 10 miles isn't precise, you'd like to treat 10 miles north of Mineral Wells the same way you'd treat, you know, 10 miles north of Leander. And so there's some really great publications out there about how you do this, but I'm not going to go into those. This is merely a factoid to sock away. It really isn't probably going to make much difference, but one of the things that we record when we record a location is the horizontal datum. And these different datums model the shape of the Earth differently. So NAD 27 was the North American datum of 1927. NAD 83 is the North American datum of 1983. And they don't, if you take coordinates and plug them in according to one, you don't end up in exactly the same place as if you use the other. Now, NAD 83, you know, maps made prior to 1983 typically were using this earlier standard. All the modern maps are using 83. All of the collections that we're dealing with and the GPS system that we're currently using use NAD 83 effectively because it's essentially identical to the World Geodetic System of 1984, which covers the entire world. And because in Specify, we've got a collection that covers the entire Earth, that's the standard we use. Now, how would this matter? In the Western United States, you can be off by 100 meters if you don't know which standard you were using. And so for most of us, that's probably not going to matter very much, but it's something that we got to take into account. When I started on this particular 3 years ago, the lab had funding to georeference all the specimens from the Western Interior Seaway during the Cretaceous. And multiple, I forget, there were 6 or 8 institutions that were working on this. all that data got funneled into, was loaded into GBIF and iDig biorepositories, so that, again, to support research into that particular time period. We had 3,000 collecting events in Texas from the Cretaceous that had not been given GPS coordinates. We finished that, and we're working on other time periods and other states. So we start with the data to specify, and we do a query, and that gives us a set of things to work on. In specify, there's a thing called a collecting event. And every specimen is associated with a collecting event, and a collecting event is associated with a location. So when we look at a collecting event, we see a locality name, a verbatim description of the locality, and this is this text string that we're going to use typically to figure it out. There's also often chronology and stratigraphy, so you can see what, what the age was, what the formation is that it's in. Sometimes there's a date. More often you have to infer that based on who the collector was. And then there's also a specimen number. And so you can follow the specimen number to the data on the specimen in specify, which tells you where it's stored, who the collector was. And if you're really lucky, there's a publication. Where the publication exists, you can often get a lot of really excellent data. In the most extreme case, you may want to go look at the physical paperwork that's associated with the specimen. But you only do that if just things don't make any sense and you want to go back to as original material as you possibly can. So this is what the form looks like. We begin with a collecting event, and the nice thing about doing this online is that you guys can probably lean in and actually read this stuff. But you can see there's a locality at the top, and that's linked. You see the little pencil over here underneath the red circle. We're going to click on that and ultimately go, and that's the thing we're going to edit. And this one has GPS coordinates in it, but we'll pretend for the purposes of this exercise that it doesn't. There's a verbatim locality here, and this says Parks Mountain, and sometimes these have been combined from multiple sources. Like there might have been multiple pieces of paper in with the specimen, and all of that data got recorded because we don't want to lose anything. So this says Parks Mountain, 1.5 miles northwest of Mitchell Crossing to the south end of Parks Mountain, blah, blah. There's a chronostrat down here, which tells us it's Pennsylvanian, the lithostrat, which tells us in the Graham Formation. And then down here, there's a link to a specimen number. So we click on the locality, that little editing button, and that takes us to the actual locality. And this is where we're going to actually fill in the information. Not all of these have even had the county that they occur in recorded. So one of the things we want to do is make sure the county data is there. So this one happens to be a location in San Saba County. The lat-long method. So we're going to talk about this tool, geolocate, in a moment, but this is the primary tool we use, and this is sort of the default entry for what the method was for determining the latitude and longitude. Here's the map datum that I was talking about, and as I said, it defaults to WGS 1984. Then the latitude and longitude are here. Those are the things we're going to fill in. Down here, it's filled in my name because I'm georeferencing this thing. It's filled in the date, and then here's where I put in the uncertainty, 160 meters. And if there are particular remarks, they go down there in the remark section. So here's basically how these tables in the database are related to one another. There's a collecting event, which has a pointer off to this locality, which has a name. It has may or may not have a number. It has a geography, a latitude and longitude, and an uncertainty. And the things we're typically trying to fill in here, we want to make sure the county data is there, and we want to get the latitude and longitude and the uncertainty. We've also potentially got this other data about particularly about the formation, which might or might not be useful. And then there's a pointer to the collection object, and the collection object has its number, what is it, what's its taxon, and again, if we were very lucky, there's a citation here. So how do we do this? I'm going to talk primarily about the four tools I use the most, but there's a lot of others, and we've been in particular, Ed and I have been trying to collect this data as we go forward. So if we find a particularly useful website or something that's a tool that we can use, we've got a link to it in the wiki. So I don't, you guys probably all know what a wiki is. A wiki is just the tool like Wikipedia that allows us as members of the lab to share information and record it in a persistent fashion. UT has this UT-wide wiki, and the Non-vertebrate Paleo Lab has got their own little section of it. And within that, we've got a little section for georeferencing. The links for all these resources that I'm going to talk about are going to be found here. So if you bring this up in the PDF, you can just click on it and you'll go there. Or you can Google UT Non-vertebrate Lab Wiki Georeference, and it'll bring you there. There's sort of two things. That's the top of the entry point to the wiki, and then the specific list of resources are here, but you'll see how to get there. There's a lot more data here that I'm going to have time to talk about, and again, it's stuff that's only useful in rare cases, but once you've figured out where it is, you want to record it. So, if you need to know where all the fire lookouts or abandoned airfields in Texas are, I've got a great source of tools for you. This is what the wiki looks like. You can see here, there's a thing on how to perform certain tasks. There's these resources I talked about. Found places, if we find something that was really tricky and difficult, we try to record on this page where it was, so that the next person doesn't have to jump through all the hoops that we did to get to it. Here's what georeferencing the resources looks like, and again, it's got all kinds of stuff. How to search for names, how to get access to historical topographic maps, stuff on Texas and US geology, Texas land surveys, oil wells. The Handbook of Texas can be a useful resource on just general Texas history. There's old county maps, links into the library, how to do township and range conversion, UTM conversion. There's a lot of stuff out there. So the tool that we do our work is centered around is this one called Geolocate, which is a platform for georeferencing natural history collections data. And this guy, Nelson Rios, has built it, and he started it at Tulane, 18 years ago. He's now at Yale and continues. We've sent him a couple of requests, and within a week, he typically enables them if they're not, really difficult. This is the link to it. He's got help on it, and one of the help files is this YouTube video, which is a really good introduction, which goes into a little more depth than I'm going to. So when you bring it up, there's a screen that looks like this, and there's a various maps you can bring up and overlays. So if you look over here, you can select the base layer, and you can, Google Streets, Bing, but typically we're focused on these Esri USGS topos because they tend to correspond to, the naming conventions and the detail that we're looking for. There are also a lot of overlays you can put on top of it. So they're historical USGS topos. We'll talk about that later. US counties can be very useful because if you click on that, at various levels of resolution, you'll see the counties outlined. And if you're looking for something on, the southeast corner of the county, that can be helpful. So when you go to look for something, down at the bottom here, you've got this where you enter the locality string. So this is where you might say 1.5 miles north of Mitchell Crossing to the south end of Parks Mountain. You have to enter, if it's in the US, you have to provide a state, so Texas in this case, and you may or may not add a county. I did here. So this is blown up. You can see what this looks like. We've told it they were in Texas and Coleman County. That original description, this 1.5 miles north of Mitchell Crossing at the south end of Parks Mountain, that's a little too complicated for it to parse. If you said 1.5 miles north of Parks Mountain, it would probably do it. But in this case, I just put in Parks Mountain, okay? And you can see here that green dot is the top of Parks Mountain, is the peak. And this circle is the radius of uncertainty that it put in. And I'm not quite sure why in this case it defaulted to something so big. Maybe Parks Mountain goes way down this backside of the hill up here. and it centers on the peak. So it said at the south end of Parks Mountain. So I can grab that little green dot and drag it down. And you see this arrow here? This allows me to raise or lower this radius of uncertainty. And down here on the bottom right, there's the latitude and longitude of that green point, and 355 is the meters radius of uncertainty. So by sort of drawing what you think the uncertainty is on here, you can get a detailed number. Now, where is Mitchell's Crossing? It turns out on that map, it's actually kind of is on that map, but you can't read it. But again, as we said, you can overlay this stuff with a variety of things, in particular, historical USGS topos. And so if I click down here on historical USGS topo, it brings up over here a list of everything that's, every historical map that encompasses this particular point. And I knew roughly what the time period was, so I clicked on Brady 1924 and got this map. And down here, you can see, voila, there's Mitchell Crossing. So I can use, there's a measuring tool in geolocate. I can go up 1.5 miles, and I know, that I'm in roughly the right spot. And the only thing I need to do is figure out, how uncertain I am about this particular location. So this can be really valuable. Also, you can control the level of, there's a scroll or a slider here, you can control the transparency, so you can see how this stuff overlaid the, say, a current Google map. The next tool that I use a lot is the USGS Geographical Name Information System. This basically contains all of the names on USGS topo maps, at least all the modern ones. So here you can see I put in Crossing, I put in Texas and Coleman. And the reason for that is a lot of times on a lot of these things, less is more. So rather than typing out the full name, I just put in Crossing, and I got 5 of them back, and Mitchell Crossing is right there. And now when you get back a feature, you get back additional information on it. I can click on this and dive in, and I'll get more data on Mitchell Crossing. And again, when I say less is more, in particular, there are some ranches, like, again, there's a ranch in, well, what's it called? Well, in West Texas, there's some ranches that differ by virtue of having an apostrophe or not having an apostrophe in your name. And they're in different counties. And so leaving off the apostrophe can be valuable. So when you get this back and you dive in deeper, and this is a case where I'm looking at Elm Creek in Coleman County, you've got all of this data. You've got, if it's in multiple counties, it tells you here, it's in Coleman and Concho County. It tells you where the mouth is. So this is the mouth of the stream. It tells you where the source is. This is the source of the stream. It tells you all of the maps that it appears on. So this, and you can, cut and paste this and go back to your maps. And I regularly use this to find places that aren't showing up well on the maps. I can grab the latitude and longitude, go back to geolocate and put it in, and it'll take me there. Here's another example. I left the county blank and I searched for Post Oak Creek. So there's a lot of those. If you look down here, by the way, this isn't all of them. There's 26 of them. So you have to look and see if there's potentially more than what you're just seeing on the screen. But one of the interesting things about this, if you look over here at what the return feature names are, so we've got all these Post Oak Creeks, sure. Little Post Oak Creek, we get why that's there, but there's Cassius Creek and Deep Creek here. Well, if you click on those and go in, you'll see that Post Oak Creek is a variant name for those, and it's careful to bring up that kind of stuff for you. So again, particularly when things are changing historically or over time, that can be really valuable. This is another tool. This is TopoView. This is one of my favorites because it allows you to dig into historical US topo maps. And essentially, again, you put in a location up here, and you tell it to search, and if there's multiple Austins, it will let you pick from them. And then it brings up all the various maps that cover that spot. And up here, you've got a slider, so you can focus in on the date if you want to. And you can also change, you can say, I only want 24K maps, which are 7.5-minute maps. Usually I don't mess with those, but what I've got here, so this is where the center of it deems the center of Austin. And what I chose was this map here from 1910. So it's Austin, Texas, 1910. And this button, before it said hide, it said show. And that's what I clicked on to see it. You can control mapping transparency. So again, you can overlay those over a current base map, and you can download them. You can download them as JPEGs or GeoTIFFs or several other formats. So it's a pretty neat tool, especially if you like old maps. And you can see, you know, Austin didn't go too far north at this point. And here, by the way, is, let's see, does it show on here? No. Well, there's a couple of old railroads in here that are no longer around. So you can search by location. You can search by map name. Every once in a while that is useful, but again, rarely. Sometimes somebody will say this was on this particular map and it's an old map, and so it's possible to go dig it up. You know, you can look for different scales, but all seems to be the best. I mean, you're going to end up wanting to use the best resolution you can get, which is typically these 7.5-minute maps. But sometimes larger scales are useful. And again, this is what you get. You can scroll through them. You can look at a recent one. You can go back to older ones if you don't find what you're looking for. It's a nice tool. Finally, one other thing. I said that the Name Information Service lists everything that's on topo maps except on really old topo maps. So sometimes it's the case that you can find things on these historical maps that is not on a modern map or is not available in the in the Geographic Name Information System. Now, this is usually not worth it. What happened was there was a new ranch name here, and I thought it was the ranch that matched Schuler Ranch, but I wasn't sure. So I went to this location on the base map and looked at an older map, in this case a San Diego Peak map from 1917, and there was the Schuler Ranch. So again, this is a case where by digging a little bit hard and using some other information, I was able to roughly zero in, go back to a historical map and find what I was looking for. Looking for a random ranch that you don't have a name for can be pretty difficult. So I suspect most of you have seen this. This is this USGS Texas geology map. It's interactive. And again, if we've considered a case where I had the location was 2 miles east of the Schuler Ranch, and the lithostrat said it was in the Boquillas Formation. So if I want to confirm that my guess about where this ranch is was correct, I can take the GPS coordinates for Schuler Ranch, plug them in up here in the search for a place, and then it will show me down here. It'll take me to that spot, and I can click on zoom to and go down to a much greater level of detail. And you get this, you get the geology map with, you know, maybe you can read it on your screens. It says KBSE. So this location here is in the Boquillas Formation because, again, if I click on this green cross-hashed area, I get this, which describes the unit in detail. So it says it's in the Boquillas Formation, tells me what of the BEG geology sheets it's on, period, series, and group. And then down here, there's a lot of additional data. Often it contains data on the members. So again, and the reason I use this rather than the overlay, there is an overlay in geolocate, but geolocate doesn't provide you this ability to pop up information about the formation. So, public land survey system. So the bad news is this doesn't apply to Texas, but it does apply to Oklahoma. It does apply to a lot of places you might go looking, particularly in the West and Midwest. This is created by the Land Ordnance Survey of 1785 to survey the land that we got in the Treaty of Paris, which was our agreement with the Great Britain at the end of the Revolutionary War. And it gave us a lot of land out further west from the colonies. So most states in the Midwest and West use this. If you see township and range in a description of a location, you're most likely looking at PLSS coordinates. We'll show you an example using one of Amazon's sites in Oklahoma. Texas, of course, has its own system, and it's based on Spanish land grants and a weird variation of a PLSS-like thing. And there's a tool that we're going to talk about that allows you to dig into those. There's a bunch of exceptions. The original colonies, Cherokee lands in Georgia, Hawaii, Louisiana, Mexico, a bunch of places for historical reasons use something different. There's a really good overview in Wikipedia on PLSS. But if you get township and range, basically you need to think of it as the township and range give you this Cartesian-like coordinate system. So there's this thing called the principal meridian, and there's a baseline. And township and range are offset from this center. So this is township 2 south. So we go down 2, range 3 west, we go over 3 west, and we're in this township. Well, townships are 36 square miles. They're divided into sections. Each section is a square mile, and the sections have this weird, they're numbered in a zigzag. So the upper right is 1, they go over, and then they go down to 7, and they zigzag back and forth. So section 14, that's easy, that's right there. And then they further describe locations in this notation using quadrants. So if you think of it as quadrant and section and township. So here it says the southwest corner in the northwest corner in the section 14 in township 2. So here's the section 14. So you start with the northwest quarter, which is, this bigger upper right rectangle is the northwest quarter. Then you take the southwest quarter of that, that's this little one down here. So boom, that's where you are. Now, and this is what the meridians and baselines look like. And one of the things you will notice is that some states have more than one meridian and baseline. So you either need to know which meridian and baseline, which meridian they're dealing with, or you need to know what county it's in. If you know the county, it's pretty much unambiguous. But you notice here's Oklahoma, the panhandle has got a separate meridian from the bulk of the state. So the good news is, and I only found this out fairly recently, in geolocate, you can use township range and sections to get to a section on your USGS topos. So if you look at this, Sitter, northeast quarter, southwest quarter, section 10, township 2, north, range 6 east, 8 miles south of Ada, that turns out to be Amazon's location for Yellow Bluff. So for geolocate, you can format this like this: township 2 north, T2N, R6 east, range 6 east, section 10. So if you don't put in the county, or you're going to get multiple results. But in this case, I'm able to put in exactly that string, and I know it's in Pontotoc County, and it's in Oklahoma. So geolocate comes up with this. So there's this green dot here. This square is the section. If you see here, that little 9, underneath this green dot, there's a 10, indicating that this is section 10. And then I use the draw polygon tool. That's, again, part of geolocate. So the southwest quarter is this one down here. And then the northeast quarter of that is this. So this orangey square is what that description leads you to. And then the center of that, of course, would be right in the middle of that, that square. Now, if we take that and we overlay it on on Google Earth, the green dot is that spot that was the center of the of that square. And those of you familiar with Yellow Bluff, this is exactly, that circle is exactly encompassing Yellow Bluff. It's spot on. So again, if you're looking at old publications, this could be pretty handy. In Texas, you need to go to the Texas General Land Office, Land Lease Viewer, and this is a lot more problematical. There's a couple of things going on here. This Land Lease Viewer, there's a pull down, so there's a variety of ways to look for something. And typically you don't have the abstract, but you may have like a survey name or a block or a section. And various of these, you can plug in that data and it will show the options. One of the problems with it is that oftentimes the names, they have just initials, and sometimes they do, sometimes they don't, and it seems to want an exact match. So this is another case where less is more. In this case, typing in just more would be better than typing in John Moore, probably. Here's one of my favorites. The lunatic asylum land. I was looking for a particular section in the lunatic asylum lands, and I actually found a map of the lunatic asylum lands, but it was a really old one, and all of the stream names, none of them seemed to correspond to anything I could find in Taylor County. But I went to here, I put in, and well, my big insight, which was kind of a lucky stroke, was to realize that lunatic land asylums was abbreviated LAL in here. So once you put LAL in the survey, it brings back these 3 highlighted areas. And they're in 3 different counties: Stevenson, Shackleford, and Taylor. And I knew it was in Taylor. And then if you zoom in on these little squares, there are section numbers in them. So using this tool, I was able to get it down to about a square mile. All right. So we talked earlier about, collectors sometimes use their own notations, their own shorthand. I had a collection event that actually looked like this. The locality was PGC B 15.5, with the verbatim locality being R103 in Seba County. Well, that's not too helpful. Worst case, by the way, we do draw a radius of uncertainty around an entire county if we don't have any more information. In fact, in some cases, we've drawn a radius of uncertainty around all of Texas because there's zero information with the thing other than it's from Texas. And if it's Cretaceous Texas, that encompasses a pretty big section. But in this case, there was a particular specimen associated with this, UT 12342B. Looking at the database, there's a publication. It's a master's thesis, Carboniferous stratigraphy of the Linter Ranch area. I was able to find Odin 58 at the UT library. In an appendix, there's a list of these acronyms. PGC is a measured section. It's the Pecan Grove Cloverleaf section. So this was 15 feet, I forget whether it's meters or feet up in the PGC section. And R103 had a detailed location description like this: what ranch it was on, immediately south of the ranch road between these 2 windmills. And then it had this additional coordinate here. There's a map in the back of the thesis, and J2 are the coordinates for a rectangular section of the map. And there's an X marked PGC. So I was able to absolutely nail it. So in the case you're lucky enough to find this, you can do pretty well. I mentioned that UT has this numbering scheme. This is something that's useful to know. These cards, these numbers are basically of the form county, and then T stands for Texas, and 32 is the 32nd identified location in that county. There are some of these for Alabama and Louisiana that have a different character there, but in general, you're looking at T's. And there's a card deck in the curator's office where I can go in, and if I don't have verbatim locality or locality name data, we can go in and look that up. Now, a lot of these localities, I should mention, are not generally available. And in fact, some of the stuff that gets uploaded to these shared databases is intentionally fuzzed a little bit because, for instance, stuff that's been found on federal lands, it's not permissible to put a precise location out there. So there's a mechanism for obfuscating that to a certain extent. And again, the nice thing about these UT numbers is if they're present and the the county isn't, we know exactly that 42 is Coleman County, so we can update that. And again, I talked about these location numbering systems unique to collectors. As we find them, we put them in the wiki. So there's a bunch of these places where we've pulled stuff out of this publication, Permian brachiopods of West Texas, and we've got a link to West Texas brachiopod location names, King's brachiopod locations. For various of these things, there's a publication somewhere, and we've been able to pull the data out and make it more readily available, or just point you to the publications. You can go look. I think good, I'm timed this about right. So one other thing that's handy is being able to look up formation names. GeoLex lets you do that. If you've got a geological name that's unfamiliar, doesn't seem to be showing up in your maps, you can go here, and here's what the page looks like. And there's a unit name. So you can type in, here I just typed in Walnut, and you click on Texas to tell it what state you're in, and then you do a search. And one of the nice things about this is if it's like a name that's no longer in use, GeoLex will tell you that. So we go to Walnut, we can see there's the Walnut Clay of the Fredericksburg group, the Walnut Formation of the Fredericksburg, the Walnut Marl of the Fredericksburg group, and the Walnut member of the Goodland Limestone. So all Walnut has been applied to all of these things. This asterisk up here means that this is an accepted term by the U.S. Geological Survey. These ones without it are names that appeared in some publication somewhere. Down here you also have typically listed the members. If I click on Walnut, that takes me to more detail. And in particular, there's this significant publications. If you want to go really dive super deep, you can, though I don't do that when I'm doing geolocating. But if it's a variant name or an alternative name or a name that's been replaced, that's going to be recorded here. And you can use this to find out what the current name of a formation is on the U.S. Geological map. All right, I'm about done here. One thing I wanted to mention were transcription errors. So there was data associated with the specimen or in field notebooks. And here's an example that you never come across. This is really abnormal. This is an incredibly good one. You got the name of the species. You've got the number of the specimen, BEG 21098. You've got the formation that was in, Eagle Ford, the Britain member. You've got the location, the Elm Fork at the Rock Island Railroad Bridge in Dallas County, the location number, and the publication. So you don't find this very often. But remember, this data is then taken and it was typed into books. The original database for the collection were a whole bunch of books that had this stuff typed in. And every time people start typing, they do make typos. Now in this case, there aren't any, there are just some changes. So on the specimen, it said river, this says R. Somebody actually put in the publication number here, which wasn't specifically listed on the specimen. Here's the age. They expanded KEF to Eagle Ford. They left off formation. One of the things that happens is things like R's sometimes look like road. Formations sometimes get interpreted. Somebody read the original label and thought it was a place rather than a formation. This is why sometimes you go back and look at other stuff. And it's also, this is one of the few places, it's actually, the fact that I know a little bit of Texas geology is useful. I found one that was supposed to be Pennsylvanian that was on the Texas coast. Now, we do have some cores where it's possible for something older to be from a place you wouldn't normally expect. But if it's not from a core and it says it's Pennsylvanian and was found in, Austin County, you know that there's something wrong. Well, this is pretty trivial, but geolocate allows you to, can simplify your life. There's some options, and if you set it to CSV, then you can cut and paste the latitude and longitude. Most tools are happy with a comma delimited GPS coordinate. These two are what you get out of Google Maps. This is hard to type. Typing the little degree can be difficult, and a lot of tools don't like this form. Virtually everybody is happy with this, but they want it to be comma delimited, not tab delimited. So it's just handy to do that. And finally, if you look at the solution stuff in the wiki, you can see how what the county numbers are, how they work. Some stuff on how to dig into things on syntax, blocks and sections in Texas, wells and leases, how to find and dig into those, depots and stations, what that means. If you've got an old depot, how to identify it on a map. Benchmarks, sometimes people list things with respect to a benchmark, but a benchmark is an elevation above sea level. So a benchmark is inherently ambiguous, but if you've got other data and you get to the right topo map from the right time period, you can actually find the benchmark. And again, benchmarks 30 years apart are likely to be different because surveying has improved and the later benchmark is more accurate. So you got to be kind of careful. There's a whole section in there on these West Texas county errors. There's a really neat excuse me, application that shows you how counties in the entire US have changed over time. This came up the other day. Ed actually wanted to translate from universal transverse Mercator to GPS coordinates, and there's some stuff on how to do that. So we'll take questions if there are any. Excuse me. So this is Mike Smith again. I first gave this presentation using Zoom at the first virtual meeting of the Paleontological Society of Austin. There was some interaction afterwards that was useful. There were some questions in the chat, and in the recording, I neglected to read the questions in the chat. I just answered them. So rather than have a rather cryptic series of audio, I'm gonna I've summarized that stuff and organized it here and gonna run through it quickly. So one of the notes that was made, Jim Sprinkle noted that he has had, for things in the Austin area, he's had luck with the Travis County Historical Commission. He was trying to figure out where an old school was located. They meet every month or two, and their website's on the slide. I've used the Austin History Center, in particular to get aerial photos of Austin in the 50s. They've got a lot of collateral, particularly old images, but they also have old maps, and they can be extremely helpful. Jim noted that Macrostat is a pretty good source for bedrock maps of the US and in particular for the world. The viewer that I presented earlier doesn't cover the entire world, Macrostat does. And he noted that they produce some mobile apps, and then later on we were talking about RockD. Well, RockD is Macrostat's primary mobile app, and it's a neat app because basically it uses your GPS coordinates to tell you what you're standing on. You can see a summary of what the formation or member is. You can flip over to a geological map, and there are some other sources of data about where you are. You can record where you are, so that can be handy. One of the questions that came up was when you're in a creek, the maps typically show it as quaternary, and I mean, in order to figure out if you're looking at something you've pulled out of a creek where the creek wall was cut into, typically that's that formation is the formation that surrounds the creek, unless it's a really deep cut into the creek and has gone into another layer. One question came up was how do you use Google Maps to get GPS coordinates? The online is pretty easy. If you right click on a map and a location, it brings up a menu that has what's here on it. If you click on what's here at the bottom of the page, it will show you a little summary with a link that's got GPS coordinates. You click on those and you end up with this image, which shows you down here there's decimal GPS coordinates, and up here there's minutes, degrees, minutes, and seconds. So Apple Maps and Google Maps on your mobile app also allow you to do this, so it's not quite as trivial. You use your finger to drop a point, And then if you can flip up at the bottom of the page on your mobile app, both of them show you GPS coordinates. However, the better thing, there are better apps for that. I use on my iPhone, I use Theodolite, and it's great for recording locations. You know, you take a picture of the location where you've just collected something, and it overlays the timestamp, the GPS coordinates, the elevation, the direction you're facing. It's very handy. You get it out of the App Store. There are equivalent apps for on Android. There are two of them that I found. One's Dioptra, and one's Geocam. I haven't had experience with either one of them, but some of our members have used one or the other of them. I'm not sure which, and they found them roughly equivalent to Theodolite. So again, these can be really useful. The only thing to watch out for is, you know, your phones are not as robust as a handheld GPS. So, you know, they can fail. Your battery can go dead, or you may not get satellites, or I typically have location services turned off. And when I turn it on, it takes a while to acquire satellites. And if I take a picture too soon, and this has happened to me, Theodolite doesn't put GPS coordinates in because it doesn't yet know where it is. Anyway, ultimately, handheld GPS will be the most dependable, but phones are pretty handy. And as Eric Rose noted, nothing ever replaces pencil and paper. And again, pencil and paper, you know, paper has the advantage of you can drop a sheet of paper in with the bag of specimens that you've got, so that 3 years from now, when you try to figure out what these things are, you can figure out where they came from. The question was asked, have I ever been completely stumped? And absolutely. Some things just can't be found. We've talked about old ranches. You know, if you can't figure out where it is, you're limited to, say, the county, if the county was recorded. If the county wasn't recorded, then you're, you know, really, if it's somewhere in West Texas, you draw a very, very large circle of uncertainty. You get descriptions that are internally consistent. Typically, this means that somebody mistranscribed stuff. They wrote east instead of west, and so you've got stuff that just doesn't make sense. And again, when typically you never fail completely, you get partway there, but that just means that this radius uncertainty gets pretty big. There are specimens that were purchased that are in the collection, and sometimes, you know, the location is Belgium. So again, the precision can vary a lot depending upon how the specimen was acquired and who collected it. For you folks that are going to donate specimens to any collection, make sure your locations are nailed down, at least within a reasonable radius. Otherwise, the stuff's going to end up in the giveaway box. That's it.